Hey, you are my last video for the day to record. Last is best, right? So I obviously haven't recorded any of your videos yet. It is almost noon. My plan was to get out of here at 11, so I didn't have to worry about packing a lunch. Um, and I was super hungry, and Leah, I'm sorry, but I broke into your Oreos. So this break's going well. I'm gonna gain weight. It's cool. Hashtag don't know if I'm gonna have a wedding season, so I guess I can. Um, so here we go. I also waited to the last minute because I didn't bring your notes home, and you're the only class that I need to actually do the notes in. So yeah, we had to get back to the school, and then I talk obviously as I'm doing right now. So yeah, I am running behind. It's awesome. I'll do better. This is a little bit more of an overhaul than I thought, but it's okay. We're doing it. All right. So we're learning something kind of really important, and that's u-substitution. And this is not the best information to do online. And our plan of sneaking to Panera is not going to work because obviously we can't do that anymore thanks to the governor's next restriction. And who knows when the next one would be. I don't even know if I'll be in my classroom again after this. They might close everything down. Who knows? So u-substitution is kind of tricky, but it's not horribly tricky, okay? It's kind of like a puzzle. Or not a puzzle, sorry. It's like playing a chess. You have to think a play ahead. So that's the only part that makes it a little difficult, but I definitely think you can handle it. So we're going to do a warm-up. We're going to not throw it back because I can't say that anymore because I learned that's a dance move on TikTok. So we're going to go back to when we first learned about derivatives, and by the way, did you hear that, Mesa, the boop boop? Yeah, I have a message because people are trying to sell me stuff because online school. Okay. Anyway, this was the original definition of a derivative, but we would have an x here and here, but there's a value here. So we have to break down what are they asking? Well, they're asking us to find the derivative of tangent when x equals pi over 6. So you definitely are going to want to have your integral sheet. Just for this problem, you'll need your unit circle, but you won't need it for the rest of this lesson. So the derivative of tangent is secant squared of x, and then we're going to plug that into the x. We're going to plug in that pi over 6 in there. So if we find the value of secant at pi over 6, which is on 30 degrees, you get 2 square root of 3 over 3, and you're squaring that value, which gives you 4 times 3 over 9, which gives you 4/3, because these simplify. So your answer is B. That's actually a problem off of the AP test. All right. We hinted at, and I just took a bite of my Oreo. We hinted at undoing the chain rule. We kind of had a small rule to it. And the first example we've actually done problems with, but I'm going to actually show you how this reverse chain rule works. Okay, so first off, the chain rule says, if you remember when we're deriving, that you derive the outside and then you derive the inside. Okay, so what we have to do to go backwards is basically figure out what's the inside to be able to integrate it when we're given a problem. So the rule for u-substitution, or the integral of a composite function, would just basically means a function is in a function. Looks like a hot mess. So it's going to freak you out. So the integral of f of g of x times that derivative of g of x, and that's like that because we're undoing the chain rule, is the antiderivative of f with g of x on the inside plus c, because we never know what that is. So what we're going to do is basically do the big kid version of substitution, like you solve by substitution in Algebra 1 and Algebra 2. This is using that concept of substituting a value in for another. but with integration. So you're going to use the u for the inside function. We're then going to derive, and then we have to basically solve for dx. And this is going to look weird, but if you look at this, that means it'd be 1 over g prime of x. If you were to solve this, if you were to move this over, times du. Sorry, I am still adjusting. Okay. I have a really bad habit of hitting this little clicker on the side of the pen, and that's what I did. All right. So this looks like a lot. And these directions help, but they don't have the best direct instructions. They don't give you what you need to do in every scenario. And what you need to do in every scenario is different. It really is. So this is basic. It's like very, very, very basic of what the steps are. You just have to think a play ahead. So we did problems like this already, which is fine. So we need to figure out, first step, what the inside function is. So this is what we have to think. What's the inside function? And if I derive it, does it cancel out the outside? Let's call it the outside. All right. So the derivative of 5x is 5. That cancels the outside of this function. So that is the right choice. So we're going to make 5x u. We're then going to derive it. Now the derivative of 5x is 5. We derived it with respect to x. So we have to write dx. And now we're going to solve for dx. So you're going to divide this over. So you get 1/5 du. Now real quick, what I'm telling everybody during this whole process is I'm moving a whole lot faster. I don't have Planet Fitness jokes to tell you. I don't have stories to tell you. I don't have Mace to say and boop boop to tell you, or Katie to complain, or, sorry Katie, I'm just joking. So I'm moving faster because I have nobody to stop me with questions. So if you get confused, stop the lesson, write it down, process it, restart the lesson or replay it. Like hit the play button. I feel like when I say restart or replay, it means like start it over, but I'm not saying that. Okay, so just think that through, that you can stop this video at any point. So we have all this information. So now we got to enter this in and this in. Okay, so we're going to rewrite this. The 5 can stay. The 5x is now u, and dx equals this. So we have to write this in. Okay, 1/5 and 5 go away. If you do not cancel something out, we're in trouble, or it's not the right method, or we did something wrong. Okay, so we have cosine of u times du. So we're deriving this with respect to u now. Normal thing that we did, all right? And the derivative, we're not deriving, we're integrating cosine with respect to u. And the integral of cosine is sine of u plus c. That's our answer. For the most part, there's just one last step. We have to plug this u back in. So we go and basically replace the x value. And we get sine of 5x plus c. And that's the answer. And we've done something like that. We have. We're just now going to step it up. We're going to undo the chain rule, which you love so much. Even more so. So now we're going backwards. Okay. So we have to figure out what the inside function is and what it could cancel out with. So thinking a step ahead. We're trying to figure out the u and figuring out the derivative of u, the du, then solve for dx. It's going to sound complicated. Cancel something out. Now, it sounds way more complicated than it is, but if you notice with what we have, if I took this x squared as plus 1 as my u, there's another one, Mesa, and you derive this, you're going to get 2x, which cancels that out. So that is the correct choice. Now, sometimes they're not as easy to see that, like visually. So sometimes you're going to have to make the wrong decision to figure out what the right decision is. So, which is life, right? You're going to derive x squared, which is 2x, plus 1 is nothing, and you derived it with respect to x. So now you're going to solve for dx, which means you're going to derive that over. I keep saying the wrong thing. You're going to divide that over. And voila. Once you get to this step, and I don't mean to have that as x, sorry. Once you get to this step, you can start plugging things in. So, National Environment Health Expert Dr. Linda Lee answers your question on the coronavirus. Good Lord. I need to turn these notifications off, but I literally haven't gotten to it yet, / I forgot. All right, so x squared plus 1 is now u. So we have u squared. U squared what? Get it? Like what did you? Okay, never mind. Times 2x times dx, but dx is this now. So I'm going to put it in brackets right now just so you can see that this took the place of dx. Okay. We're good because what happens is these two x's cancel. We're left with u squared du, and we integrate. And with the integral, remember, you add the 1 power and then you do the reciprocal of that. So 2 plus 1 is 3. Reciprocal is 1/3. We get u cubed and plus c. We integrated it, so now we just have to enter the u back in. You do not actually have to FOIL that out. And voila, we have our answer. Oops, no we don't. Oops, 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 oops. I wrote you. Not you, but you. Get that one? I'm really losing my mind here without you guys. Okay, so that's our answer, okay? So just to let you know, we are going to do up to example 5. I'm going to stop the video, and then I'm going to restart it. So I'm kind of chunking it up a little bit so it's not as overwhelming. And then I'll try to post other links to other examples if I remember. So I'm not going to lie, I really want to go home and eat lunch. All right, so next page. All right, so when we do this, again, we have to think of what is the inside of a function. And when we derive that, does it get rid of anything? So inside, this is inside of the square. If I take the derivative of x squared, we get 2x. The most important thing is that it's canceling out a variable or a function. If it doesn't cancel out a number, we can work with that. So x squared plus 1 is what we're going to do. If we derive that, you get 2x dx, because 1 is 0, and we derived it in respect to dx. And then we would divide that 1 or that 2x over and get 1 over 2x du. So we we divided that over and we got this. Okay, so let's see what happens. If we use u-substitution, we have x times u squared. So we took care of this. We're taking care of the dx. And dx is 1 over 2x du. All right, the x is canceled. That's the important part. This 1 over 2 can actually be kicked out to the front, leaving you with 1/2 and the integral of u squared du. Now we integrate this. We add the 1. We already did one like this. It becomes 1/3 u cubed plus c, leaving us with 1/6 u cubed plus c. We did it. We got it. Not too bad. All you do from there is replug the u back in. Again, don't need to FOIL it. And that's your answer. Now, I think with these problems where it's just powers like that, and kind of 4, it's not too bad. It does get a little trickier when they're sine and cosine and exponential functions and rational functions, okay? So bear with. I have 9 examples. It's quite a few. It gives you a good example of what's going on. If you need help, you can message me and I can record myself more so you can hear me more. I know you're excited. All right. So, see, there we go. I clicked it again. All right. So we know this right here. All right. We know this right here is the same thing as 2x minus 1 to the 1/2 power. Okay. And that is no different than, let me go to it, this problem right here. I mean, there's no 2x, but it's the same as number 2 and number 3, the way you go about it. So what I would like for you to do, mainly so I can eat my Oreo, I'm not going to lie. Thanks again, Leah. I want you to try to do this problem on your own and see how far you can get, because you're not going to be able to do this unless you try it on your own here. where you can still hear my voice and me trying to help you. Okay, so try the problem, see how far you can get, start the video if you get stuck. If you get done with it, start the video. You can always fast forward and see what the answer is, okay? So go ahead and pause the video now. Okay, I'm back. So, there I go again. Dang it. Dang it. All right. You can still hear the order in my voice because obviously I can't pause myself in this. You're pausing the video. I'm not. All right. So the inside's 2x minus 1. You're going to derive it, and that gets you 2dx. And then you solve for dx, and that gives you 1/2 du because you're dividing that over. Not deriving. I actually said dividing. Okay. We're then going to replace the information we have. So the 2x minus 1 is now u because we used u-substitution. And dx is now 1/2 du. All right, so there wasn't really anything to cancel out here, which makes life easier, but still some things to do. So we're going to kick out that 1/2 before we integrate it because I know we're all about that. And then we're going to integrate it. So kind of an easier problem, but the square root makes it look tough. You're going to add the 1, which gives you 3/2. Okay. The reciprocal of that, because we have to multiply by the reciprocal, is 2/3 u to the 3/2 power plus c. So that's the integral. The 2 is going to cancel, which leaves you 1/3. And we are going to put the u back. Now, when I did my notes on my own, like to get ready for this, I put this back into radical form, but you don't have to. Just leave it like that. With what we're dealing with, I feel like I can go a little lax on you and let you get away with something. So that's our answer. That's it. All right. 5. All right. Number 5. Same idea. Kind of. We have this. We know the square root is 1/2. Okay, so let's rewrite it. And I told you this is a chess move. You have to think ahead. So this is ultimately the inside function. There is no doubt that that's the inside function. But as we derive it, we're going to notice we don't get rid of this x. Okay. And then as we keep on going, we're really noticing that we can't get rid of that x. And then as we do this, we notice we can't get rid of this x. So there's a problem with this. It's actually not going to be possible. Okay, because I can't cancel the x. And if you can't cancel out that function, then you literally either did something wrong or you can't go any farther. And on this one, it's not possible. As of right now, you really need to use what's called integration by parts. And that is next on our list. So this is not possible as of right now. Okay, so not a great example. All right. I'm going to end the video here, and then I'm going to restart it up with 6, because that's where we're going to start doing a little bit more complicated integration, or u-substitution, sorry, but it's really not that difficult. All right, see you in the next video.